Researchers warn us that something unusual is happening on the sun, and it's already affecting us. If we want to protect our Earth and our lives, we must act. Our sun is a source of life, but it's also a furnace of destruction and could bring our civilization to the brink of collapse with a single powerful solar storm. Researchers are now urgently trying to find a solution to the inevitable. Without our star, we would not exist. Without the sun, there would be no heat and no light, and the cosmic radiation would probably turn our globe into a wasteland. The sun constantly sends streams of plasma into space, and thus envelopes us in a mantle that reliably shields us from the radiation of interstellar space. The heat and light emitted make our planet pleasantly warm. Plants can grow, we have light and warmth, and a climate conducive to life. Things look different just a little closer to the sun. Life would not be possible on Mercury, and further away from the sun, where it's dark and cold, our food base could not survive. The sun is a giver of life if it's in the right proportion to a planet and the planet has a protective atmosphere. But the sun can also destroy. If its protective radiation becomes too much, chaos could break out on Earth. Researchers are certain that a solar storm is coming that is so powerful, it's currently difficult for us to estimate its effects. We desperately need to know more about our star, and this is exactly why NASA has set up the Solar Dynamics Observatory. Are we on the brink of the solar apocalypse? What few of us realize is that we are constantly dependent on the sun's influence, whether at night or during the day. This powerful furnace fires charged streams of particles into space around the clock. Our Earth is used to living with these solar winds, and we even benefit from them. Just as a little sun is nice to get a tan or relax, too much can cause nasty damage. Normally, the Earth's magnetic field reliably redirects the solar winds and traps the particles in the upper layers of the atmosphere, which we can occasionally see as auroras. However, this does not always work, and in special cases, extreme ultraviolet light penetrates into the deeper layers of the atmosphere. Then, sparks could fly from power grids, or your cell phone would suddenly report a blackout. Does that sound crazy to you? But that's exactly what happened in 1859 when the last devastating solar storm paralyzed electrical systems and the telegraph network. Scientists are certain that the next storm of this magnitude will change our civilization forever, and they're sure it's coming. Imagine looking out your window in the morning and seeing strange bright lights in the sky. In 1859, people saw purple auroras in the middle of the USA. Then, you try to switch on an electrical appliance, but it won't work. The humming of your fridge has already stopped. When you pick up your cell phone to see what has happened, a few sparks strike you. You look out of the window and see people walking down the street, looking up at the sky. It's the same everywhere. The power's gone. Phones no longer work. No internet, nothing. Nobody but a few people know what's going on. Maybe your administration's cars are driving through the streets with loudspeakers asking you to keep calm. If you want to go to work, there's nothing you can do, because computers, streetcars, and many other things will simply stop working. The refrigeration systems in the supermarket will fail. The checkout systems will go on strike, and the electric security doors won't even open. Perhaps the blackout will be over after a few hours, but it could also last for days or even weeks. Mankind will be lucky if there are only isolated accidents. At the beginning of the solar event, airplanes could get lost, and ships could collide on the oceans. In addition to the power grid, all communication and radio networks would have collapsed. What sounds like the script of a science fiction movie is a scenario that could be triggered by a massive solar storm at any time, any day. This looming shadow hangs over us, and almost nobody notices it. Astronomers monitor the sun around the clock so that they can issue a warning if necessary. But once the storm is broken loose, it only takes 10 minutes or 1 hour to reach us. Can solar research save us? The sun is an incomparable giant, a powerful and dynamic force that has been the center of the solar system for more than 4 billion years. It's the source of the light and heat that make life on Earth possible and a place of fascinating activity, constant flux, upheavals of gigantic proportions, and impressive storms that are breathtakingly beautiful but also dangerous. The most striking phenomena are sunspots, which are dark areas on the surface of the sun. These areas are significantly cooler than their surroundings and are evidence of the sun's turbulent magnetic activity. These spots follow a cycle that lasts about 11 years. During the peak, the so-called solar maximum, sunspots are more numerous, and solar activity is more intense overall. The sunspot cycle is now considered to be well studied, and like solar flares, it's actually easy to predict. But then things happen that shock our researchers quite unpredictably. The sun can be prone to sudden bursts of radiation and the release of strong magnetic energy. Coronal mass ejections periodically hurl huge amounts of plasma into space. As a rule, we don't notice any of this. All we ever see in the sky is the big yellow ball glowing as if nothing had happened. It's only when we look through special telescopes that the violence, but also the beauty, of the fireball is revealed. We enjoy the warmth of the first rays of sunshine in spring, blossom in summer, or delight in beautiful auroras, but UV radiation can also burn our skin, damage plants, and scorch the soil. Solar activity is unpredictable in many ways. Scientists can predict general phases of the known cycles, but the exact timing and intensity of individual events such as flares and coronal mass ejections remain difficult to predict. Furthermore, researchers do not yet know whether the sun has other cycles that we are not yet aware of. Violent events, such as the solar storm of 1859, could be part of a cycle that leads to massive ejections every few hundred years. Astronomers first recognized the connection between solar activity and the blackout event in 1859. Before that, these natural spectacles probably went unnoticed because humans did not yet use electricity. The unpredictability of our star shows us once again how small and insignificant we are, even on the scale of our sun. And imagine that even our sun is a comparatively small star in a sea of billions of stars that are up to millions of times larger and more powerful. Studying solar activity and cycles is critical to our survival. What news does NASA's SDO have? NASA's Solar Dynamics Observatory, or SDO, is a groundbreaking space telescope designed specifically for observing the sun. Since its launch in February 2010, the SDO has ushered in a completely new era in solar research. Thanks to state-of-the-art filter technologies, the observatory provides us with unprecedented insights into the dynamic processes of the sun. The aim of the mission is clearly to perfect our understanding of the sun and its effects on the Earth and the near-space environment. The SDO is part of NASA's Living with a Star program, which aims to understand all aspects of the Sun-Earth connection, including all aspects that directly affect life and society. To do this, the observatory works with a range of sophisticated instruments that observe the sun at different wavelengths. The Atmospheric Imaging Assembly, AIA, provides images of the sun's atmosphere in multiple wavelengths of ultraviolet light. These images are crucial to understanding the complex dynamics of the solar corona, including the formation of sunspots, flares, and coronal mass ejections. It's only through filtering that the finest details become visible, and a storm that would be devastating to us is actually no big deal to the sun. With the Extreme Ultraviolet Variability Experiment, EVE, the world's most modern solar observatory measures ultraviolet radiation from the sun. This data is extremely important for understanding the sun's influence on our atmosphere and the Earth's climate. The helioseismic and magnetic imager, in turn, studies the movements and magnetic field of the sun's surface, which is crucial for understanding the internal dynamics of the sun and its magnetic activities. One of the most remarkable features of the SDO is its ability to deliver data in near real time. Thanks to this fantastic data transmission rate, we get a complete picture of the sun and its current activities every 12 seconds. In an emergency, this real-time transmission can provide important benefits. We have to remember that a solar storm may only take 10 minutes to reach us. All the data provided by the SDO will significantly improve our knowledge and prediction of solar storms. We will hopefully be able to better protect our satellites, communication systems, and power grids in the future. The second hope for mankind is currently NASA's Parker Solar Probe. This groundbreaking space observatory was specially developed to study the sun at close range. It was launched on August 12, 2018, and since then, the probe, named after astrophysicist and solar pioneer Eugene Parker, has been periodically approaching our star to study it in detail. This mission is unique, as no probe has ever flown as close to the Sun as this one. The main task of the Parker Solar Probe is to study the Sun's outer atmosphere, the corona. There, it will collect data to answer three fundamental questions of solar physics. Why is the corona hotter than the surface of the Sun? The surface of the Sun, the photosphere, has temperatures of around 5,500 degrees Celsius, while temperatures of several million degrees can prevail in the corona. This phenomenon is known in astrophysics as the corona heating problem and remains one of the greatest mysteries of solar research. The second question we urgently need to answer is what drives the solar vortex in the first place. The Parker Solar Probe will help to understand how the solar wind of charged particles is accelerated and moves through the entire solar system. Finally, we will get answers to how solar flares and coronal mass ejections occur. These powerful eruptions can have potentially dangerous effects on Earth. During these events, the Sun emits up to 1,000 times more particle fluxes into space than usual. Of course, neither the SDO nor the Parker Solar Probe will be able to actively protect us, but knowledge will give us an advantage in the future. Power companies, communication companies, and technicians will have to learn a lot about the Sun and the properties of its radiation. We need to design power grids that can withstand the huge amounts of radiation and protect our communication equipment.